Okay, so the quadratic formula is one thing that when you ask people about algebra, if they've taken it recently, that's the one thing that they usually remember, or at least they may not remember the actual formula, but they know the name. They're like, oh yeah, I remember doing that.
Yeah.
So where this formula comes from is from completing the square. That is a section that we skipped in the textbook. That was 9.2. So we skipped that. It is covered in college algebra. It's not used very often, which is why we are not even bothering covering it in this class.
Okay.
But if you do that process on a quadratic, and they actually, 9.3, which talks about the quadratic formula, actually shows the work for that, though it's probably not going to make any sense. But if you're curious, you can go look at it. But you do that process on an equation without any numbers, and that's how you get a formula. So this allows us to solve any quadratic equation, though it is best to solve by factoring whenever possible because it's a lot faster than trying to use the quadratic formula. So when you're solving a quadratic equation, there are three different types of solutions. So you can get solutions that are rational numbers, which means that you're going to get a whole number solution, or you're going to get a solution that you can write as a fraction. You have irrational number solutions, and that's where you're going to get square roots in your answers. And so then you have to simplify your square root. And there are times when you get no real solution at all because you get a negative number inside the square root, which we can't do. So those are the three different types of solutions that you get. And the first type, if you get a solution that's a rational number, that means you could have factored that, because factoring always results in rational numbers. So whenever possible, I try to factor just because it's quicker. But there are some where you just cannot factor and you have to use the quadratic formula.
Okay.
So basically all we're going to do is just practice using this formula. So it's in the box here, x equals negative b, and then that's our plus or minus symbol that we saw when we were dealing with simplifying square roots. Because the square root, you can get a positive or a negative number, like the square root of 4 could be positive 2 or negative 2 because both square to get 4. So we condense that into a plus or minus symbol so that just, instead of writing two separate equations, we can write one equation. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that's the formula, and it's the process to simplify that usually takes a lot of steps. Is very prone to math errors. So it's something that you have to be very, very careful with, and that's why it's like, okay, if you can factor, definitely do it by factoring. So this first one here, this is one that we can solve by factoring. So I'm going to do it first by factoring, and then we're going to do it by using the quadratic formula so that you can see a comparison of how many steps it takes. And as you notice, I left a lot more room on the quadratic formula side. So we have 3n squared plus 5n minus 2 equals 0. So when we factor this, it's going to be factored into two sets of parentheses, and then we have the equal 0 on the right. So I have 3n squared, and the only two numbers that multiply to 3 are 1 and 3. So I can write this as 3n and n. So 3n times n will get me 3n squared. Now in the back of these two parentheses, I need to multiply to negative 2. So the only numbers that multiply to 2 are 1 and 2. And to get to a negative, one has to be a negative number, one has to be a positive number. And so it's just a matter of figuring out which spot they go in. So since we're adding to 5, when I look at these, and I know they have to be opposite numbers, so if they're opposite numbers, then I know that I'm going to have to do some sort of subtraction here. So if I make my outsides multiply to 6, then I can do a subtraction on the inside, and that gets me to a positive 5. So that gives me a 3n minus 1 times n plus 2 equals 0. So that gives me 6n minus 1n. That gives me my plus 5n. And then I have a -1 times 2. That gets me my -2. And we know we have the 3n squared. So I factored. And it didn't really take much guessing and checking at all. So when we solve by factoring, once you factor, you set each factor equal to 0 in its own equation. So I have 3n minus 1 equals 0, and n plus 2 equal to 0. And then you solve each of these for n. So for the first equation, I'm going to add 1 to both sides. And that will give me 3n equals 1. And then we're going to divide both sides by 3. And we get n equals 1/3. Then the second equation, I have n plus 2. So I'm going to subtract 2 from both sides. And that gives me n equals -2. So that's my second answer. So we factored, you set each factor equal to 0, then you solve for the variable, and that gives us our 2 answers.
When do you use the solution set again?
So that would be, so if you're doing it on paper like this, you can just box them like I did, but in Connect Math, when it asks specifically for the solution set, it's just giving you a different way to write your answer.
Okay.
And so that's where you'd put it in set notation. And they usually put the curly braces in there for you already, so all you have to do is put in the numbers.
Yeah.
And that's, I think it's coded that way just because it's a lot easier to just put in the numbers, comma, rather than trying to write them in as equations. But when you're doing math by hand, you can just box your answers like I did.
Okay.
So now on the right, I'm going to use the quadratic formula. And so our quadratic formula involves A, B, and C, and these come from our coefficients. And so these are the numbers in our form. So A is always the number in front of the squared term. So A is equal to 3 in our equation. B is always the number in front of the single variable, so B is going to be equal to 5, and then C is the constant, so that's -2.
Okay.
So we have to label A, B, and C, and then we need to make sure that we plug them into the correct places in our equation here. So the quadratic formula is x equals, but if our variable is n, we now have to write that as n equals. It's just written with x because that's the most common variable.
Okay, that makes sense.
So in our equation, or in our formula, we have -b. So I'm going to have my negative, and then b is equal to 5. So that gives me -5.
Mm-hmm.
Then I have my plus or minus, and then I'm going to have my square root. So b squared, so that's going to be 5 squared, because that's what b is.
Mm-hmm.
Then -4, and then times a, so that's times 3, and then times c, so that's times -2, and then making sure that I'm extending my the square root all the way across those, and then I have to make sure that the whole thing is on the fraction, so my fraction bar has to cover that whole thing that I just wrote, and then we have 2a, which is 3. So the most common error at this point is either making a sign error or putting the wrong number in the wrong location. So once we've plugged everything in, now we're following the order of operations on the right side, and we need to simplify. So because I don't have a lot of space here, just writing that equation took up a lot of space. I'm going to be sort of zigzagging, and that's completely fine. So I'm going to go to the right, and then go under, then go to the right, and just kind of zigzag until I get to the end. So I've got my -5. We're not doing anything there, and then the plus or minus. And the first thing we want to do is simplify inside the square root. So inside the square root, we're following the order of operations. And so we don't have order of operations going inside with parentheses. All we have here are exponents and multiplication. So the exponent comes first. So I'm going to do 5 squared, which is 25. And then I've got my minus 4 times 3 times negative 2. And then usually in the same step, I will multiply in the denominator as well, because that's simple enough to do right there. 2 times 3 is 6.
Yeah, okay.
So next step, now we need to still simplify in the square root. We need to do the multiplication. So I'm going to first rewrite everything. My minus 5 plus or minus, and then I've got 25, and then minus, then 4 times 3 times negative 2. So I can multiply all of those together. So 4 times 3 is 12. 12 times negative 2 is negative 24. So we've got 25 minus a negative 24. And we can turn, because we're subtracting a negative, we could write that as adding 24, because the two negative signs make a positive.
Oh, wait, now. Oh, I see, because, oh. So the answer was negative 24, but.
It became positive because we have this negative sign, because we're subtracting the negative 24. So subtracting a negative becomes adding.
Okay, great. Okay. Those are the things I miss.
Yeah. So next, we're still simplifying under the square root. Now we need to do the addition. So I'm going to move to the right again. Negative 5 plus or minus square root. And then 25 plus 24 is 49. And then we have over 6. And then at this point, you need to take the square root of 49. So this is where your calculator comes in handy. If it comes to a whole number, that's awesome, and you just keep the whole number and you keep working your math. If it comes to a decimal, that's where we have to simplify square roots, like chapter 8. So in this case, the square root of 49 is 7. So this gives us negative 5 plus or minus 7 over 6. I just keep writing my n there. So now that all I have left is this plus or minus symbol, and we can't add things together with the plus or minus symbol. In order to add or subtract those, we have to write them as two separate equations. So this is where you split it up, and you have two equations. You have one of them with the positive sign, so n equals negative 5 plus 7 over 6. And then you have the other one with the negative sign, negative 5 minus 7 over 6.
Okay.
Because we can't really add and subtract at the same time. Those are opposite things. So that's where we split it up.
Okay.
And then here, we need to actually simplify on the top, do our addition and subtraction. So the first one I have is negative 5 plus 7. So that comes to 2. So that's 2 over 6, which reduces to 1/3.
Mm-hmm. And
then the second equation, negative 5 minus 7 is negative 12. So negative 12 over 6 divides to negative 2. So you get the same answer, but it's a lot more work.
I agree.
So quadratic formula will always give you an answer, but it is more work. And frequently, when someone tells me they're running out of time on the exam this week,
yes,
where they have to do this, it's because they're using the quadratic formula every time when they could speed things up by factoring. So don't try to do the quadratic formula on every problem, because it will slow you down. But It always works, so there is that comfort. Angie, yes, go ahead. You have a question.
Hi, ma'am. So you just mentioned not to do the quadratic formula on every problem, even if it's asking for it.
If it's asking for it, I'm not testing whether you're actually doing that or not. I just want you to be able to solve. So if it's one that you can solve by factoring and it tells you the quadratic formula, go ahead and solve by factoring. Just as long as you get an answer.
Thank you.
Yeah. That was an excellent question. Are there other questions?
So what you're saying is to solve, go ahead and try factoring first, and then if you run into
Yes.
problems, go to the quadratic. Okay.
Yeah, if it's something that you can't factor quickly, it might be faster to do the quadratic formula.
Okay.
In my video last week, I talked about how like doing the AC method is slower than necessarily factoring if you can factor really quick, guess and check. But like something like this where the numbers are really small, I always just try to factor first because there's not a lot of choices. It goes pretty quickly. And if you can't factor it pretty quick, then the quadratic formula you're probably going to end up having to do anyway. Yes, Andy, go ahead before I move on to the next one. Go ahead.
Never mind. I was just gonna ask if you can do one where it gives you a decimal.
Oh yes, I've got,
Thank you.
I've got that. I even have one where it gives us a negative. I have all of those planned out. So this, and I don't remember which order I have them. So this one might actually be one to give a decimal. So we've got 2a squared plus 5a equals 1. Now, in order to use this equation, you have to have it equal to 0. So we have to subtract 1 from both sides, essentially, so that we can have everything on one side, because that's how this works. And then I can't subtract 1 from anything with an a, so just it's just rearranging it. So we have 2a squared plus 5a minus 1 equals 0. And that's the base that we have to always start with whenever we're solving a quadratic. Now, this one does not factor, and I can look at that right away because the front numbers have to multiply to 2, the back has to multiply to 1, and there's not any way to get to 5. I could get to, like, I could do 2 times 1 and then a 1. I can get to 3, but I can't get to 5. Just impossible. So I can just look at it, and I've done enough factoring that I look at it, I'm like, yeah, no combinations work. So we would have to use the quadratic formula in this case. So I'm going to start by labeling all of my numbers. So a is equal to 2, b is equal to 5, and c is equal to -1. And instead of x equals, we have a equals, because that's our variable. So we have our formula -b, so that is -5 plus or minus, and then b squared, so that's 5 squared again, minus 4 times a, which is 2, and then c, which is -1, and then the whole thing is over 2 times a, so that's 2 times 2. And just make sure every time you're writing these by hand that you have your lines extending as long as they need to be so that you don't accidentally leave things off. So just like before, I am going to do my exponent first, that 5 squared. And then I'm also just going to do the multiplication in the denominator. And I'm going to just move to the right because it's just much, much easier. So I get -5 plus or minus square root of 25 minus 4 times 2 times -1. And then 2 times 2 is 4. So next thing under the square root is we're going to do this multiplication. So we've got, and we've got this -4 times 2 times -1, or you can think of it as subtracting 4 times 2 times -1. But just like on the previous example, these two negative signs are going to give us a positive there. So we have, keep switching my pen colors here, -5 plus or minus square root. We've got our 25. And then I'm going to get a positive because the two negatives become a positive. And then 4 times 2 is 8. And then times the 1, that's 8. So we get 25 plus 8. And then we have 4 in the denominator. So next is to add 25 and 8. So that's -5 plus or minus, and that comes out to 33. So we have the square root of 33 over 4. Now, in your calculator, if you take the square root of 33, you are going to get a decimal. You're going to get 8 point something. And if you're solving an equation like this and it's a word problem, we will usually convert it to the decimal, because word problems we don't normally, it's okay to round. But if it's just solving and there's no word problem associated with this, we need to keep it in exact form, and that means leaving it in square root form. So we want to try to simplify the square root if possible. Now in this case, the square root of 33 does not simplify, because 33 is 3 times 11, and those are both prime numbers. So we can't take square roots of either one of them. So this is already simplified, so we have to leave it as the square root of 33. So now is where we split it up into our two separate equations. So I don't know if you, like, sometimes it helps people to kind of write arrows if they're going to do it, just to kind of remind them that they're going to write two equations. Normally I do my math all vertically, and I wouldn't go left or right over this, and so then I would do my two like right underneath it, maybe like this, to indicate I got two answers, but that's not going to leave me enough room here. So I'm going to kind of modify how I'm writing my work here, but I usually just go straight down. And yes, you may use like a whole piece of paper, but when you're doing problems like this, if you do columns, like if you put 2 columns on a piece of paper, you can at least get multiple problems on a page. So we can't simplify the square root of 33, so I'm going to now rewrite that plus or minus. So we've got a equals -5 plus the square root of 33 over 4, and then a equals -5 minus the square root of 33 over 4. That is completely fine to write your answers like this, because we can't really add -5 in the square root of 33 because they're not like terms. One has a square root, one doesn't. But you may also have see these written out with as multiple fractions. So that way you don't have it all over a single fraction. And so how that works is you just take each of the top pieces and you write them over the denominator. So that would be -5 over 4. Then we have our plus. And then you could write it as square root of 33 over 4, but we usually write it as a 1 in front of the square root. And so we could do it like 1/4 times the square root of 33. So that's another way to write it. So if there's no number in front of the square root symbol, you can just put a 1 there when you're trying to split these up. I think Alex will take either one, or not Alex, Connect Math will take either one. I don't think you have to write as the way on the right, but if you get numbers that look like they will reduce, you do want to do it the way on the right. Otherwise, I think you can leave it as the way on the left. They're equivalent. It's just a matter of how does it want you to give the answer.
Okay.
And the same thing on the second one here, you can split it up. You'd have a -5/4 and then a -1/4 times the square root of 33 if you wanted to write it that way. And the only advantage to splitting them up like this is if you do see that you can have fractions that you can reduce. That's the only advantage. If nothing reduces, if there's nothing that you can like divide out or anything, you could leave it in the previous step. Are there questions?
Nope.
Angie, does this help you?
Yeah, it did help. I have a question. I was gonna wait maybe if there was an example of it. So -5 plus the square root of 33/4. So if there was a number before the square root of 33, it would be, I don't know if the question's making sense. I'm sorry.
You would put it like where I have the 1/4, you would put the number there instead.
So if it was, let's say, if it was a 2, it would be 2/4, and then it'll reduce to 2.
It would reduce to 1/2.
To 1. There you go. Okay. So
Yeah.
you reduce it. Okay. That's what I was having trouble with on the examples. Okay.
Yeah, and that's usually happens when you have a square root that you have to simplify, and then you start pulling things out of the square root. I can't remember if my next example does that or not. So if it does, we'll find out.
Okay. Thank you.
Yeah, the thing about these is that if you want to get a quadratic equation that's not factorable, it's really easy to make up problems because most of the time when you make up numbers, they don't factor. So. So let's actually take a look at my next one here. And this, when you look at it, we have 2y times y minus 3 and then equals 1. It doesn't look like it's quadratic because you don't see anything that's a squared. But in order to solve this, we'd have to multiply through the parentheses, and then that's where the squared appears. So if we distribute, we get 2y squared. And then we have a 2y times -3. So it's going to be -6y equals 1. And then you see, oh, this is a quadratic. I have something squared. So now I have to put everything on one side to solve. And so just like the previous example, we'd have to subtract 1 from both sides. And that would give us 2y squared minus 6y minus 1 equals 0. And so then quadratic formula. Because again, this definitely does not factor. So let's see, A is 2 again in this case, because that's the number in front of the squared. B, in this case, we now have a negative. So B is a -6. And then C is -1. So it gets very tedious doing these problems. If anybody asks you what's tedious about math, it's definitely using the quadratic formula because you're just doing the same thing over and over and over again. Oops. So our variable is y, so now I'm going to have y equals. And now here's a little trick that a lot of people, it's not a trick, it's just a point where people mess up. We have -b. B is already negative. So you end up with two negatives. It's a negative b, which is negative, then negative 6. So whenever you have a negative, it's best to put parentheses around it when you plug it in. So that way you still have that negative, and then b is negative 6. And this is true underneath the square root as well, because we're squaring a negative 6. So make sure you have parentheses around that. And we've got our minus 4 times a, which is 2, and then c, which is negative 1. And then in the denominator is 2 times a, so that's 2 times 2. So when b is negative, you want to be very, very, very careful to make sure you have the correct number of negative signs. Because if you mess up your signs, it messes up the whole thing. So what I usually do in this step is I will do the negative times negative 6 here, because those two negatives cancel out, that becomes positive. And then, of course, I do the exponent part, so that's squaring the negative 6. And I'm also going to do the multiplication of the denominator. And I could do each of these in its own step, but because it's already a long process, I try to do as few steps as possible. I mean, if you really wanted to, you could also do this multiplication as well. So let's just go ahead and do that. So you can do that as well. So, oops, let me make sure I'm on the right pen color. So I got a negative times negative 6, so that's a positive 6, plus or minus. Now negative 6 squared is a positive 36, and then minus, and then 4 times 2 times negative 1, that's negative 8. Or you can do 36 plus 8. And some people on their paper will just do something like that, turn the negative and then the parenthesis and the negative into that plus sign. So that's one way to remind you that a negative times a negative is a positive there. And then in the denominator, 2 times 2 is 4. So yeah, this is looking like one where we're going to end up with a number in front. So Angie, you're like predicting what I have, my examples. It's like you read my mind. So I'm going to do the 36 plus 8. So I've got 6 plus or minus 36 plus 8 is 44. And I just wanted, I'm pretty sure that's right, but I just want to double check it on my calculator, just because if you make a mistake here, it messes up everything. And then we have 4 in the denominator. So square root of 44 can be simplified. And so this is where I usually do some scratch work off to the side. I don't have a lot of room here because I'm trying to keep all of it on the same screen. So I'm going to just do my little factor tree out here on the right. So 44 is 4 times 11, and 11's prime. And we can take the square root of 4. So we can also turn that into 2 times 2, which are prime numbers. So what I'm going to do is rewrite the square root of 44 as the square root of, I've got 2 squares, so that's 2 squared, and then times 11. So I have 2 2's and then the 11. And then that's over 4. And when we're simplifying square roots, anything that has an exponent that's even, we can pull out of the square root. You're basically dividing the exponent by 2, because the square root of something squared, those cancel out. And so our exponent here will disappear. And so we end up with a 2 that is going to be outside of the square root when we pull it out. So this will give me 6 plus or minus 2 times the square root of 11 over 4. So this is exactly the situation where we end up with that number in front of our square root. And so to simplify this, it's best to write it as two separate fractions so that you can see clearly what you're simplifying and making sure that you're reducing things correctly. So I'm going to write my two separate equations here. Actually, I'm going to do this in a different color so that it doesn't, there's so many things going on here. It's kind of hard to keep track on the very limited space here. So we've got y equals 6 plus 2 times the square root of 11 over 4. And then y equals 6 minus 2 times the square root of 11 over 4. And so I am going to split these fractions up. So we have 6 over 4, then plus 2 over 4 times the square root of 11. And then I can reduce each of these. So 6 over 4, I can divide them both by 2. That leaves me 3 halves. And then 2 over 4 reduces to 1 half. And then I have the square root of 11. And then basically, it's going to end up with the same thing on the right, just with the minus. We're going to have 6 over 4 minus 2 over 4 times the square root of 11. So this gives us 3 halves minus 1 half times the square root of 11. So if you wanted to save a little bit of space, what I could have done is I could have actually split these up with a plus or minus symbol in between. So, and reduced at that point if I wanted to. So that's an alternative step to do. If I could have split it up before making the two equations, and I have that plus or minus, and then I could reduce them and then do the two equations. It's kind of up to you which way you want to do it. I always make my two equations once I simplify the square root. So that's just what I did here, because that's just the order that I always do things. Are there questions?
You make it look so easy.
When you try to do this, doing the quadratic formula is something that you have to do lots of practice on for it to really get easier. Yeah. There's so many moving pieces. Yep. There's so many things you have to think about, putting numbers in the right place, doing the order of operations, making sure you know how to simplify square roots. There's just tons of things going on.
Yep.
Like the worst thing in math is like if you miss one sign, the whole problem is wrong.
Yes. And that's why we have you turn in your work on the quizzes to get partial credit, because the computer doesn't know that. Yeah. I've certainly done that on problems myself. Particularly in the higher level math, where once you get into really high levels of math, like if you get to calculus 2, there can be a single problem that takes over a page. Sometimes you have a page and a half to do a single problem. And if you make one mistake at the very beginning, you have to redo the whole thing. And I've definitely had to do that. So yeah, it's very time consuming, but once you get the answer, it's so satisfying. And actually, computer programming is a lot like math in that way, because you can do computer code, write all this stuff, and then it's not working. And you have to go back and see where your one little error was. Maybe you're missing a semicolon, and that makes the whole thing break. Maybe you put a plus instead of a minus, or you actually put the wrong letter. It's the same thing. So you need to be very, very detail-oriented in math and in any programming, because the littlest thing can throw everything off. So as promised, this one is going to give us a negative inside the square root to kind of show you what that looks like and how it works. Again, this one would not factor. There's no way to get this one to factor. So we would have to do the quadratic formula. So I don't know why for every single one of these I started it with 2. I should have had more variety on A because those are getting, I had one of them where it's 3, but it's like I'm just picking the same numbers over and over again. C is not -1 in this case. So we got A is 2, B is 1. So if there's no number in front of there, it's going to be 1. And then C is 5. So I've got my X as my variable. And so we've got negative B, and B is 1, so that's going to be -1 plus or minus square root, and then 1 squared, so that's, or B squared, which is 1 squared, minus 4 times A, which is 2, times C, which is 5. And then the whole thing is over 2 times A, so that's 2 times 2. So I'm going to square my 1, which is just 1. And then I'm also going to do this multiplication at the same time, and this multiplication at the same time. Just easy enough to do, saves some steps. So I've got -1 plus or minus. So 1 squared is 1. Then we have our minus, then 4 times 2 is 8. 8 times 5 is 40. And then 2 times 2 gives us 4 in the denominator. So you can see that we're going to get a problem here when I subtract, because I'm going to do 1 minus 40. And so that is going to give us a -39. And if you try to take the square root of a negative in your calculator, you're going to get an error. It will just say error. And that's because we can't take the square root of a negative number and get a real number. And so when you end up with something like that, I'm going to highlight it. So this square root of 39, when you end up with the square root of a negative, that is telling you that there is no solution, or at least no real number solution. So you can't take square roots of negatives. So there is no real solution. That is our name for it. Now, when you get to college algebra, you will learn about imaginary numbers, and those are what you get when you take square roots of negatives. And so once you learn about imaginary numbers and complex numbers, then you can solve a problem like this. And imaginary numbers, complex numbers are really useful in engineering fields. So without them, we wouldn't really have electricity or anything like that, because AC electricity that we have, alternating current, uses imaginary numbers and complex numbers. So they're called imaginary. They're not actually imaginary. They're real. It's just a terrible name. But that's something that is covered in college algebra, is how to deal with square roots and negatives. But you guys don't need to know that here. And if you're not really into engineering, you're probably never going to really encounter it. So as far as this class goes, there is no real solution to these problems. And sometimes we have an abbreviation of basically like a 0 with a line through it. That, oops, I got rid of my lovely blue. The 0 with a line through it is a shortcut. Oh my goodness, I know I just, I accidentally, there is an erase button on my stylus, and I think I accidentally hit it as I was erasing or trying to highlight. So that little symbol with the line through it, that just means it's the empty set. It means no solution. So that is sometimes a shortcut that we use to indicate no solution. It's not, sometimes people write their zeros with a slash in it, and I don't recommend doing that because it looks like the symbol. So that's how like, you got to be very careful about how you write your numbers and how you write all of your stuff, because then it starts looking like other things. Are there any questions on this example?
So the answer is actually you just write no real solution. You don't have to circle
Yes.
anything. You don't have to. Okay.
No, you don't really have to circle anything. And I think in Connect Math, there will be like, they may have you just click the words no real solution, or they may use this symbol. I can't remember what they do. Sometimes there will be like it's like a multiple choice, and you say there is a solution, and then you write in the number, or you just say there's no real solution.
Okay, and there wouldn't be empty solution set.
Oh, you know, that actually, I'm glad you brought that up. That is an alternate way to write this. You could literally write it as an empty set.
Okay.
So that is an alternative to write that.
Okay. Alrighty.
So these you can solve with the quadratic formula, but you don't have to. I don't think, I mean, we don't have enough. I'm not going to actually solve these, but I want to go through just why you would not use the quadratic formula here. So for the first one, we have two terms. We don't have that last term. We're missing something. So we have 2x squared plus 5x plus, and then we don't have anything there. That last term is 0. So here we have a equals 2, b equals 5, c equals 0. When c is equal to 0, that means you have something that you can factor, and you can always factor out the greatest common factor. And so this, I wouldn't even, if you see that your c is 0, don't even bother doing the quadratic formula. Factor out your greatest common factor. Now, an example on the right, we also have two things, but we're missing the middle term. So b is equal to 0 in this case. So we have a equals 9, b is equal to 0, c here is negative 16. So when b is equal to 0 here, you can use the quadratic formula, but I would try to factor first. And that is because we usually have a difference of 2 squares, which is factorable. Or if you don't want to solve it this way, now that you guys have learned about the solving by the square root property, you can solve it that way. So actually, that's probably the faster way to do it. So I would just skip that. I wouldn't even try to factor. I would just go straight to the square root property. And that was section 9.1, where you basically make the square root by, or you make the squared part by itself. So you put 9x squared by itself, divide both sides by 9, and then take the square root to solve it. So that's faster than doing the quadratic formula. You'll get the same answer, so you might as well do it the faster way.
Thank you.
Yeah, any tricks to make it faster so that you're not wasting your time on a really long process.
Yeah.
So my next two slides here are just a summary here. So these are going to be good to like when I email this out for you to print these out or copy them down. Basically, you know, when to use the quadratic formula and then the overall steps. So make sure you rearrange it so everything is multiplied out and it's all on one side. So you have something equals 0. Identify your A, B, and C. Plug your values into the quadratic formula, and then you evaluate by following the order of operations. Like that's the overall steps that we did here. Next slide is I've actually written down sort of the order that you want to do the stuff on the right side. So you're simplifying inside the square root first. So you do your exponents, your multiplication, your subtraction and addition. You're going to simplify the square root. You make sure you multiply the denominator. You got your two equations from the plus or minus. Then you add or subtract on those numerators on the tops as possible, and you simplify fractions. So I tried to take everything that I was doing and kind of put it into a step-by-step thing here to kind of help you out because there is a lot of steps going on.
Very nice. Thank you.
You're welcome. Now, of course, some of these you can do out of order, like the plus or minus. I talked a little bit about that, but if you follow this order, this will work out for you just fine.
Okay.
And so that was it. That was the end of my thing. So any other questions on the quadratic formula or what I did today?
I'm sure if I was to try an equation by myself right now, I'd probably have a question, but
try to follow the notes and then, you know, when you get this in your email, make sure you print this out and follow it step by step.
Yep, I'm going to. Thank you.
Mm-hmm. All right.
All right.
Well,